Hello everyone. So for this lecture also we will see about the three-phase alternator. In the last lecture we have seen about the construction and working principle of three-phase alternator. But for this lecture we will see about the resistances, inductances, that is synchronous resistance, armature resistance, as well as in this some basic terms related with the winding of alternator. That means some basic terms which are mostly useful for designing of any three-phase alternators. As well as we will see about the three-phase alternators EMF equation. That is EMF equation of three-phase alternator. Okay, all these parts are very important for your career as well as for this subject. So we will move for this lecture. Now, first we will say about some basic terms of alternator. So we will go for one by definition for one by one. So coil pitch, the distance between the two sides of a coil is called as a coil span or coil pitch. Okay. So this I have shown the diagram related with all these definitions. So we will say about the coil pitch. The definition is given as the distance between the two sides of a coil is called as a coil span or coil pitch. That means simple here. Now, just we will see the detail about all these things. Pole pitch, the angular distance between the central line of one pole to the central line of next pole is called a pole pitch. Okay, and as well as the full pitch coil, short pitch coil. So, in the first part, we will say about detailing about the coil pitch. Okay, as the definition stated, the distance between the two sides of a coil is called a coil span or a coil pitch. Okay, just see this particular figure. Now, as we know that this is a particular structure of the armature as well as the stator as well as the rotor side of alternator. Okay, so this is NNS and these are the pole which is placed in the stator side, while this part is having a rotor side. Okay, and as we know that the alternator has a rotor winding, simple called as armature winding. Okay, and these are the slots. Here is particular, these are the slots. It is a particular, like these are nothing but slots. Okay, and in these slots these slots are used to provide the वाउंडिंग हाऊसिंग. ओके, म्हणजे सिंपली काय, ह्या पूर्ण स्लॉट्स मध्ये आपण काय करतो, वाइंडिंग जे आहेत अल्टरनेटरचे आपण वाइंडिंग इथे फिक्स करतो किंवा फिट करतो. ओके, गॉट इट. म्हणजे so these are the part of stator and while these part are the rotor, there is a rotating part. Okay, so just in this particular figure, in this one, so suppose I am assuming that, so these are the NNS pole, that means this part. Okay, this part I am talking about NNS pole, these are the NNS pole. So suppose I am inserting one wire, म्हणजे माझे काही एक पूर्ण रेड कलर दाखवले, पूर्ण एक वायर आहे. ओके, मी काय केलंय, ह्या वायर मी स्लॉट मध्ये इन्सर्ट केले. जस्ट लुक दिस पर्टिक्युलर स्लॉट्स, हे जे स्लॉट्स आहेत त्या स्लॉट्स मध्ये मी काय केलेलं आहे, आतमध्ये मी इन्सर्ट केलेलं आहे. दॅट मीन्स दिस वन, इथून माझं एक टर्न आहे, एक वायर इथून मी फिक्स केले आणि इथं हे डायरेक्टली अशा टर्न मधून मी पूर्ण डायरेक्टली एक कॉइल पूर्ण एक वी कॉल्ड वन टर्न. ओके, वन सिंपली मी एक टर्न वायरचं कंप्लीट केलं. म्हणजे सिंपल एक लॉंग वायर आहे, मी वायर काय केलं इथून डायरेक्टली आय एम कनेक्टेड, आय एम इन्सर्टिंग दिस वायर इन टू पर्टिक्युलरली स्लॉट, इन दिस पर्टिक्युलर स्लॉट. Now, आणि just particularly from this, that means at the end I call this is nothing but an end connection. Here I got the end connection, and this part, okay, this part we are going to connect to the commutator segments. Okay, म्हणजे इथं हा जो पार्ट आहे वाइंडिंगचा, हा पार्ट आम्ही काय करतोय, तर आम्ही हा पूर्ण पार्ट कम्युटेटरला कनेक्ट करतोय. हा इकडला एंड जो एंड आहे, दिस एंड वी आर गोइंग टू कनेक्ट टू द कम्युटेटर, while this end we are going to connect ऍज अ एंड कनेक्शन्स. म्हणजे काय, सिंपली मी एक लॉंग वायर घेतली, हे वाइंडिंगची वायर आहे, आणि मी ह्या पूर्ण स्लॉट्स मध्ये इन्सर्ट केलं आणि हे परत इथून ह्या स्लॉट मधून पूर्ण बाहेर घेतलं. ओके, सो दिस आर नथिंग बट अ सिंगल टर्न कॉइल. अगेन what I am doing in the second multi-turn coil. What is multi-turn coil? Simply मीच काय केलं, परत हे मागाशी सांगितलं की बाबा हे अशी इथून वायर आत म्हणजे स्लॉट मध्ये फिक्स केली आणि परत ह्या स्लॉट मधून बाहेर घेतलं. म्हणजे सपोज इथून स्लॉट मध्ये वाइंडिंग आहेत ना, त्या स्लॉट मध्ये फिक्स केले आणि या स्लॉट मध्ये बाहेर काढलं. असं गोल वाइंडिंग असतं बघा मोटर मध्ये. ओके, सो हिअर इथं काय केलंय, जे इथं मागाशी सिंगल टर्न जे बाहेर कम्युटेटर देणार होतो त्याच्याऐवजी मी काय केलं, परत डबल टर्न ह्यातनं फिरवलेलं आहे. ओके, दॅट मीन्स इन दिस पर्टिक्युलर सॉर्ट आय एम प्रोव्हाइडिंग द अगेन मल्टी टर्न. ओके, म्हणजे एकच टर्न न करता आय एम प्रोव्हाइडिंग द मल्टी टर्न. दिस वाइंडिंग इज कॉल्ड एज अ मल्टी टर्न कॉइल, दिस कॉइल इज कॉल्ड एज अ मल्टी टर्न कॉइल. ओके, नाव वी विल सी अबाउट द कॉइल साइड. म्हणजे काय झालं, इथं या पूर्ण इथं या वाइंडिंग मध्ये मी सॉरी या स्लॉट मध्ये मी वायर आत फिक्स केले, इथून मी बाहेर घेतलेलं. ओके, सो दिस पर्टिक्युलर साइड आय कॉल्ड कॉइल साइड. दिस इज हा पूर्ण म्हणजे काय, हा सगळा झाला कॉइल झाला माझा. ओके, म्हणजे स्टार्ट फ्रॉम दिस म्हणजे कॉइल सपोज इथून स्टार्ट झाले असेल, स्टार्ट फ्रॉम दिस इज नथिंग बट टोटली कॉइल. हे पूर्ण कॉइल झाले. कॉइल म्हणजे सिंपल काय, जे आपण कॉइल म्हणजे वाउंडिंग करणार आहे. ओके, वाउंडिंग कसं केलंय, ह्या पूर्ण मी आर्मेचरच्या स्लॉट मध्ये मी वायर इन्सर्ट केलेली आहे आणि इथून मी परत ह्या दुसऱ्या स्लॉट मध्ये बाहेर घेतले. म्हणजे फॉर एक्झाम्पल ह्या इथं बघितलं तर ह्या स्लॉट मधनं मी इन्सर्ट केलं आणि इथून परत मी बाहेर घेतलं. ओके, आणि मी काय सांगितलंय, दिस एंड जे एक एंड आहे, आय कॉल दिस इज द एंड कनेक्शन. एंड END एंड connection, while this end I'm going to connect to the commutator segments. Okay, now in the multi-eternal coil, now what I am doing now, instead of directly going to commutator, I am again wounding the same wire through the previous slots. म्हणजे परत इथून हे तुम्हाला मी काय केलं, इथून परत हे वायर इथं मी वाउंडिंग केलं. ओके, दिस पर्टिक्युलर स्ट्रक्चर वी कॉल्ड एज अ multi-eternal coil. Okay, now we are going focus for the coil side. Okay, so this part म्हणजे जे पूर्ण वाइंडिंगचा हा जो पूर्ण पार्ट आहे, आय कॉल्ड एज द कॉइल साइड 1 आणि दिस इज सेकंड द कॉइल साइड. म्हणजे ही पूर्ण एक कॉइलची एक बाजू झाली. कॉइल साइड म्हणजे काय, कॉइलची एक बाजू, साइड म्हणजे बाजू. ओके, कॉइल साइडची एक बाजू कॉइल साइड 1 आणि सेकंड बाजू म्हणजे सेकंड साइड म्हणजे कॉइल साइड 2. ओके, अगेन इथं पण कॉइल्स, इथे एक कॉइल साइड, ही बाजू, इकडली एक बाजू, इकडली एक बाजू. ओके, नंबर ऑफ द वाइंडिंग मे बी सिंगल टर्न और मल्टी टर्न. वाइंडिंग कितीही टर्न्स असू दे, कॉइल साइड्स प्रत्येक कॉइलला, एका कॉइलला दोन साइड असणार आहेत. ओके, हिअर वन कॉइल इज देअर, सिंगल टर्न आहे पण कॉइल आहे ते. ओके, पण ह्याच्यामध्ये काय, कुठल्याही कॉइलला ऑलवेज कॉइल साइड्स आर ऑलवेज 2 नंबर. म्हणजे इथं ही एक कॉइल साइड दोनच बाजू असणार प्रत्येक कॉइल साइड. ओके, नाव व्हॉट इज अ कॉइल पीच, द डिस्टन्स बिटवीन द टू साइड्स ऑफ अ कॉइल. म्हणजे या इथल्या ह्या कॉइल साइड आणि ह्या कॉइल्स म्हणजे जो काही डिस्टन्स आहे, डिस्टन्स म्हणजे काय, सिंपल काय, तर हे पूर्ण मधले स्लॉट्स आहे बघा. इथं मी काय केलं, ही वाइंडिंग इथनं आत घातलेलं आहे, पुन्हा हे रिकामं ठेवलं, हे रिकामं ठेवलं, हे रिकामं ठेवलं. आणि जो काही मधला डिस्टन्स म्हणजे काय झालं, ह्या पूर्ण 1 2 3 म्हणजे स्लॉट्स आहेत ना आर्मेचरचे, दिस इज कॉल्ड एज अ कॉइल पीच. ओके, that is coil pitch nothing but a distance between the two sides of a coil is called a coil span or simply called as a coil pitch. Both word we are using for the same definition. Okay, म्हणजे simply I'm inserting the winding here through this particularly armature slot and I'm taking outside from this slot. The different slots are, म्हणजे इथं काय केलं मी नंबर, इथं मी इथून वायर परत एक नंबर, ह्या सपोज एक माझं सुरुवातीला 0 नंबर आहे, परत वाइंडिंग इथनं बाहेर घेतला नाही आणि इथे मी इन्सर्ट केलंय वाइंडिंग ह्या पूर्ण 4 नंबर मधून बाहेर घेतलं. ओके, सो दिस डिस्टन्स बिटवीन दीज टू कॉइल साइड्स आय कॉल्ड एज अ कॉइल पिच. दॅट इज अ डिस्टन्स बिटवीन टू साइड्स. हे जे दोन, ही एक साइड आहे, ही एक बाजू कॉइलची, ही एक बाजू, या मधलं जो काही डिस्टन्स आहे, डिस्टन्स सिंपल काय, हे जे मधले स्लॉट्स आहेत ना, म्हणजे मी काय केलं, इथं इथं घातलं आणि 4 मधलं बाहेर काढलं, म्हणजे काय 1 2 3 हे मधलं गॅप आहे किंवा डिस्टन्स आहे, दिस कॉल्ड एज अ कॉइल पिच. Next definition we'll say about the pole pitch. Okay, the angular distance between the two central line, the central of one pole to central line of other pole. Simple लक्षात कसं ठेवायचं, the peripheral distance between these two. Okay, pole pitch म्हणजे काय, आता now ह्या दोन adjacent pole मधलं distance I call the pole pitch. Okay, pole pitch nothing but the distance between the two adjacent pole. म्हणजे काय, adjacent म्हणजे काय, near about जवळचा. Okay, so I'm placing here n pole is here second n pole, here s pole and s pole. The distance between these two poles, that means you can see this, the distance between these two, angular peripheral distance between two adjacent pole, angular peripheral, this is nothing but peripheral, this is nothing but angular distance. Okay, the angular distance between these two pole I call the pole pitch. म्हणजे काय, here the pole pitch is in between the distance, इथलं हे मधलं अंतर आहे n आणि s मधलं, म्हणजे ह्याचा सेंटर, n चा सेंटर आणि s चा सेंटर घेतला. ओके, ह्या एस च्या सेंटर पासून यांच्या सेंटर पर्यंत जो का मधला आहे तो डिस्टन्स अँग्युलर आय कॉल दिस इज अ पोल पिच. अगेन ह्या एनचा सेंटर आणि ह्या सेंटर मधला जो का डिस्टन्स आय कॉल्ड द पोल पिच. ओके, पोल पिच म्हणजे द अँग्युलर डिस्टन्स बिटवीन द टू ऍडजस्टंट पोल और टू नियर अबाउट पोल और टू नियरली पोल, दिस इज कॉल्ड एज अ पोल पिच. म्हणजे इथलं डिस्टन्स, ह्या इथलं समजा मी या पोलचा सेंटर काढला, ह्या एन पोलचा सेंटर काढला, या सेंटर टू सेंटर जो काय अँग्युलर डिस्टन्स आहे आय कॉल्ड इज अ पोल पिच. ओके, नाव अ पोल पिच ऑलवेज has 180 degree electrical degrees regardless of number of poles on the machine. This part is always called as a 180 degree electricals. It doesn't depends on the number of poles. Now we are going to for next the full pitch coil. Okay, full pitch coil and short pitch coil. This is most important part of any machine winding. So this is nothing but a full pitch coil. A coil having a span equal to 180 degree electrical is called as a full pitch coil. म्हणजे सिंपल काय झालं, आता फॉर एक्झाम्पल मी काय केलं बघा, आता मी सांगितल्याप्रमाणे काय मी इथनं वायर आत घातली, या इथनं म्हणजे इथनं वायर आत इन्सर्ट केले. इन्सर्ट केल्यानंतर काय केलं, इथून परत मी बाहेर आउटसाईडला घेतलेलं. ओके, म्हणजे इथलं थोडक्यात वायर इन आहे, इन घेतलंय आणि इथं परत आउट आहे, एक्झिट आहे. म्हणजे इथलं एंट्रन्स आहे, इथं एक्झिट आहे. ओके, वायर इथून मी इन्सर्ट केली आहे, इथून आत परत हे वाउंड केलं, परत इथून मी बाहेर इथं घेतलं. ओके, मल्टी सेम प्रिन्सिपल. नाव मी सपोज इफ द कॉइल स्पॅन म्हणजे काय, ह्यातलं डिस्टन्स, दोन कॉइल स्पॅन मधले डिस्टन्स. इफ द कॉइल स्पॅन हॅव्हिंग 180 डिग्री इलेक्ट्रिकल, म्हणजे काय, ह्या तुम्हाला माहिती की एन आणि एस या दोन पोल मधलं पोल पीस मध्ये ऑलवेज 180 डिग्री असतं. ओके, म्हणजे पोल पीस इज नॉट जस्ट अँग्युलर डिस्टन्स, इट इज नियरली ऑलवेज इक्वल टू द 180 डिग्री इलेक्ट्रिकल. सो हिअर जर जर माझं कॉइल पीच किंवा सिंपली कॉइल पीच जर 180 डिग्री असेल, म्हणजे इथनं म्हणजे हे पूर्ण वाइंडिंग ह्या दोन्ही मधलं म्हणजे हे दोन्ही इन्फ्लुएन्स ऑफ एन एन एस पोल असतील 180 डिग्री असेल, तर वी कॉल दिस इज नथिंग बट अ फुल पिच कॉइल. फुल पिच म्हणजे काय, मी सगळं पूर्ण पिच यूज केलेलं आहे. पिच म्हणजे काय, इथलं बघा, जस्ट आपण जशी क्रिकेटची पिच असते, म्हणजे बॉलर एंड करून बॅटिंग जो मधला पिच आहे. ओके, म्हणजे सपोज हे पूर्ण जर मी सपोज इन द वाइंडिंग सेशन सपोज आय एम युझिंग द होल पिच or called a full pitch, then this called as a full pitch coil. ओके, म्हणजे सिंपल काय, इथं माझं पिच इथून चालू झालं म्हणजे कॉइल पिच इथून आहे माझं. ओके, म्हणजे ही एक एंड आणि ही एक एंड, जे दोन एंड आहे त्या दोन एंड पूर्ण जर मी वाइंडिंगला पूर्ण हे दोन्ही पिच यूज केलं, आय कॉल इट्स अ फुल पिच कॉइल. And suppose I'm not using this pitch, I call it short pitch coil. Short pitch coil we will see later. In the first part we will see the full pitch coil. Full pitch coil, that means what, a coil having a span equal to 180 degree electrical. Okay, it's called a full pitch. दोन्ही जर पूर्ण pitch use केलं, I call it a full pitch coil. Now, in case of full pitch coil, the two coil sides span distance exactly equal to the pole pitch of 180 degree electric. As we know that pole pitch distance is always 180 degree. So this distance, this coil side, this is coil side 1, this is coil side 2. If my distance of coil pitch is 180 degree, okay, pitch the 180 degree असेल, तर I call this is a full pitch coil. Okay, now let EC1 and EC2 be the voltages generated in the coil side. Okay, this means here voltages is generated, ह्या पूर्ण coil side ला सपोज मी म्हटलं की EC1 इतकं व्होल्टेज जनरेट झालंय आणि ह्या coil side ला EC2 इतकं व्होल्टेज जनरेट झालंय, बिकॉज आय नो दॅट स्टेटर किंवा आर्मेचर मध्ये व्होल्टेज जनरेट होते. सो सपोज आय assume that EC1 and EC2, that means for EC1 this voltage is generated in the coil side 1 while this EC2 is generated in the coil side 2. Now total EC, that is the resultant coil voltage EC equals to EC1 plus EC2 because both are in connected in series. हे दोन्ही सिरीज मध्ये असल्यामुळे दोन्ही इथल्या व्होल्टेजचं ऍडिशन होणार आहे. दॅट इज टोटल EC equals to EC1 plus EC2. Now assume that EC1 equals to EC2 equals to, म्हणजे पूर्ण काय, इथं पण E व्होल्टेज जनरेट होतं आणि इथं पण E व्होल्टेज जनरेट होतं. That means since EC1 and EC2 are in phase, the resultant coil voltage EC is equal to their arithmetic sum, simply because all these are connected in a series connection, in phase connection. So we can take directly addition. So total EC is equals to EC1 plus EC2, that is a 2E. म्हणजे simple I call EC1 इथलं व्होल्टेज, here E voltage is generated E and here E, this E plus E that called as a 2E. Okay, now we'll move for the short pitch coil. Now a coil having a span less than 180 electrical degrees is called as short pitch coil or frictional, actually fractional pitch coil, frictional pitch coil. It is also called as a chordate coil. CHO, chordate coil, not a chordate. It's called a chordate coil. Okay. Previously, the coil span is having a 180 degree. You can see this. म्हणजे इथे ही माझी coil side आहे. Coil म्हणजे coilची एक बाजू, ही दुसरी coilची दुसरी बाजू. Okay. हे जर पूर्ण यातलं distance जर 180 degree असेल, I call it as a full pitch coil. But in the short pitch coil, the distance is not 180 degree. It is always less than 180 degree. And if a coil having a span less than 180 degree, it is called as short pitch coil or fractional pitch coil. It is also called a chordate coil. म्हणजे मगाशी काय होतं, इथं दोन्हीमध्ये 180 डिग्री डिस्टन्स होतं, but here we are getting the near about less than 180 degree distance. So this particularly coil we called as a short pitch coil. Okay. Now a stator winding use a frictional pitch coil is called as a chordate winding. If the span of coil is reduced by an angle alpha electrical degrees, the coil span will be 180 minus alpha electrically shown in the figure. That means what? माझे मी काय केले, pitch फक्त माझा पूर्ण pitch इथं आहे. मी suppose दोन्ही operators I called a full pitch, but now I am for this winding I am using only this part, that is this part. So this particularly coil span we call it as a 180 degree minus alpha. This is alpha is nothing but a correlating angle. इसका difference है ना. Here, as we see, this particular alpha is nothing but it's a we call it nothing but a chordate angle. Okay, or simply called as a this particularly this alpha degree we call it a chordate angle, which is always in electrical degrees. Okay. Now, as stator winding using a frictional piece coil is called as a chordate winding. If the span of coil is reduced by an angle alpha electrical degrees, the coil span will be 180 minus alpha. That is electric as shown in figure. Now, for full pitch coil, I am using this both pitch. That means I coil side, my winding start from this coil side 1 to the coil side 2. But for this short pitch coil, I am using only the coil span of 180 minus alpha. Alpha म्हणजे कुठला degree इथला degree. Okay, totally my distance is 180 degree. जी इथून इथपर्यंत माझं काय 180 degree distance आहे. But I am using only 180 degree minus alpha. That means for this short pitch coil now, I have the coil pitch of 180 minus alpha degree. Okay, now if the coil span of single coil is less than the pole pitch of 180 degree, the voltage generated in each coil side are not in phase. The resultant coil voltage EC is equal to phasor sum of EC1 and EC2. As we know that here at the coil side 1 we are using generating EC1 as a voltage. Here EC2 voltage. Previously, directly we are making an addition, that is here EC1 and EC2. That because of this end connection, I am taking as a EC equals to EC1 plus it. There is nothing but arithmetic sum. But because of this alpha degree, we call the chording angle degree. We are not taking here directly as a phasor sum, so arithmetic sum. So for addition of these two voltages, we should require the phasor addition of these voltages. Okay, that means total EC, that is resultant coil EC, is equal to the phasor sum of EC1 and EC2. Previously it was directly numerical addition, that means EC1 plus EC2. But because of this alpha degree, chording angle degree, we are taking as a phasor sum of these two degrees. Now, if the coil span is reduced by an angle of alpha degree electrical, the coil span is 180 minus alpha electrical. The voltage generated EC1 and EC2 in the two sides will be out of phase with respect to each other by an angle alpha electrical degrees as shown in figure 2. The phasor sum of EC1 and EC2 is EC, that is AC. That means now previously I am taking an addition, but for this I am taking as a phasor sum. That means I am plotting here EC1 and here EC2. Here you can check, now previously it was direct line, that means here this one, it's a voltage EC1 and EC2 both are in phase. The total voltage is EC here. Okay, this EC1 and EC2 both are in phase, so directly I'm taking as a EC as a per phase directly in phase voltages. But here both are not in phase, that's so I'm taking as a phasor addition. Okay, phasor sum. So EC1 and here EC2, whatever this angle we call it as a alpha degree. It means chording angle, it's called a chordate angle. It's alpha degree. And now here total EC, that is total this plus this whole EC1 plus EC2 voltage, we call it the total EC, we are getting as a here AC, that means total EC we are taking as a phasor sum of EC1 and EC2. So these parts are most importantly used while in winding or any design aspects of three-phase alternators. As we seen about the coil pitch here, second is a pole pitch and full pitch. Coil pitch, distance between the two pole is distance between the two adjacent coil side is called the coil pitch. Pole pitch म्हणजे काय, हे distance between the two poles I call a pole pitch. कॉइलच्या साइड मधलं अंतर कॉइल पिच, पोलच्या साइड मधलं अंतर पोल पिच. फुल पिच कॉइल म्हणजे काय, जर हे सगळं 180 डिग्री असेल म्हणजे काय, म्हणजे कॉइल इथून स्टार्ट झालं आणि ह्या दुसऱ्या पोल बसल्या इथून जर बाहेर पडली आउट झाली तर आय कॉल्ड फुल पिच. हे जर आधीच instead of using a whole coil set, suppose it is using a somewhat, then we call it a short pitch coil. Name itself gives information, short pitch coil. So it have 180 minus alpha degree. Okay. So in the next part we will see about these are nothing but definitions. So here we are taking again the coil span factor or pitch factor. Okay. Generally the coil span factor or pitch factor is defined by using the word Kc. Okay, Kc is nothing but a coil span factor or this particularly pitch factor. Kc is defined as the ratio of the voltage generated in a short pitch coil to the voltage generated in the full pitch coil. The coil span factor is also called as a coiling factor. That means these are nothing but a ratio. So this Kc, that is a coil span factor or pitch factor. Now this definition we can define with the help of this ratio: actual voltage generated in the coil divided by voltage generated in the coil span of 180 degree rectifier. Or it is also the definition: phasor sum of voltage of two coil side, arithmetic sum of voltage of two coil side. By using these two, we can take that. That means here AC is equals to AB plus BC. This we call it's a arithmetic sum. Okay. So this Kc we call it as a Kc equals to cos alpha by 2, and this alpha is nothing but alpha is nothing but just the coiling angle. म्हणजे इथला जो अल्फा आहे हा अल्फा म्हणजे काय तर तुमची हा तुमचा कॉर्डिंग अँगल आहे किंवा तुम्ही शॉर्ट पिच अँगल आहे. ओके, शॉर्ट पिच अँगल म्हणजे तुमचा अल्फा डिग्री. सो आय एम टेकिंग द केसी इज हा वर्ड केसी विथ सिंपल काय कॉइल स्पॅन फॅक्टर ऑफ डिस्टन्स फॅक्टर पिच फॅक्टर इज डिफाइंड विथ द हेल्प ऑफ द वर्ड केसी. ओके, so Kc equals to cos into cos of alpha by 2. Alpha is nothing but its coiling angle. For its most important definition, for full pitch coil, alpha equals to 0 as we seen here. Full pitch ला काय alpha नाहीच आहे ना इथं, त्यामुळे 0 degree. So for full pitch coil, alpha equals to 0. So cos 0 by 2, a simple cos A by 2 alpha equals to 1. Cos 0 is always value 1. So and hence Kc is 1. Okay, that means for full pitch coil, always the coil span factor Kc value always 1. You should remember these words. Okay, for full pitch coil the coil span factor is always 1 because for full pitch coil alpha value is 0, cos 0 is value 1. So we are taking as a Kc equals to 1. For a short pitch coil, Kc is always less than 1. As we seen for a short pitch coil, this alpha degree for this Kc is always less than 1. Again, there is one more factor we call a distribution factor, which is defined by the Kd. Okay, Kd is nothing but a distribution. D चा distribution येता है, K चा, C चा, coil span चा C येता है, K चा. Okay, K distribution factor is defined as a EMF with distributed winding divided by EMF with concentrated winding. Okay, so you should remember only this formula. ह्यातला डेफिनेशन फक्त हा फॉर्म्युला लक्षात ठेवायचा आहे Kc चा, Kc इक्वल्स टू cos अल्फा बाय 2, आणि हा Kd चा फॉर्म्युला लक्षात ठेवायचा आहे, Kd इक्वल्स टू डिस्ट्रीब्यूशन फॅक्टर इक्वल्स टू sin of m beta by 2 divided by m into sin beta by 2. You should remember at any cost, you should remember this formula. म्हणजे इथला Kc चा फॉर्म्युला तुम्हाला लक्षात ठेवायचा आहे आणि इथं तुम्हाला हा Kd चा फॉर्म्युला लक्षात ठेवायचा आहे. These formulas we are going to use for EMF equation of generator as well as to solve the different numericals related with the EMF equation of alternators. So here this Kc equals to cos alpha by 2 while the Kd is equals to sin of m beta by 2 divided by m into sin beta by 2, where this beta is equals to 180 divided by number of slots per pole. Number of slots per pole is called as a beta, and m equals to number of slots per phase per pole. M, this word m is equals to number of slots per phase per pole, and beta equals to 180 divided by number of slots per pole. Okay, so you should remember, for example, you should remember only these two formulas. Kc equals to cos alpha by 2. C indicates coil's C, coil span factor, while this Kd indicates distribution factor, Kd distribution factor. So next we will move towards the EMF equation of alternators. So this is nothing but it's an EMF equation of alternators. Then what amount of voltage or EMF is generated in the alternator we are going to see through this formula. This particularly information we are referring from the reference books, and it is similar to that of EMF equation of transformer. Already you have seen about the EMF equation of transformer in the previous semester, DC machine transformer. Similarly way we are taking the EMF equation of alternator. So let Z equals to number of conductors or coil sides in a series per phase. Total Z म्हणजे काय, total it's nothing but a Z is nothing but a number of total number of conductors is equals to 2T, where T is the number of coils or turns. म्हणजे इथे जे बघितलं तुम्ही हे नंबर ऑफ कॉइल्स, इथे मल्टी टर्न हे बघितलं तुम्ही, एक टर्न किंवा ही कॉइल आहे. ओके, आणि हे तुमचे टर्न्स, ही सिंगल टर्न म्हणजे फक्त एकच कॉइल ना, हे टी. ओके, सो दिस Z equals to number of conductors or coils in series per phase. P equals to number of poles. F equals to frequency of induced EMF in hertz. Phi flux per pole in Webers. Again, as we know that Kd equals distribution factor equals to sin of m beta by 2 divided by m sin beta by 2. Kc, that is the coil span factor, equals to pitch or coil span factor equals to cos alpha by 2. Already we have seen in this particular diagram. Now Kf, that is called from, actually from, not from factor, it's a form factor 1.11 because it's of EMF, and n equals to rotor RPM, that is a n is equals to speed of alternator. Okay, now in a one revolution of rotor, that is a in a 60 divided by n second, each stator conductor is cut by flux of 5p vapors. Okay, it's in suppose my now my alternator is start rotating. Now what will happen if the rotation is completed one revolution, then the stator conductor cuts by the flux of 5p vapors, because flux already they are placed in this particular field circuits. So therefore d into phi equals to 5p and dt equals to 60 by n seconds. Now, the average EMF induced per conductor is equals to d phi by dt. That means we're taking the derivative of this part, d phi by dt equals to 5p divided by 60 by n, phi np divided by 60. Okay, so this is similar to your EMF equation of DC generator as well as EMF equation of transformer. Now we know that F, that is a F equals to P n divided by 120. म्हणजे सिंपल की आपल्याला माहिती आहे NH equals to 120 F upon P. हा फॉर्म्युला आपला NS चा सिंक्रोनस स्पीडचा फॉर्म्युला आहे. त्याच्यावर मी काय केलं, फ्रिक्वेन्सीची व्हॅल्यू फाइंड केली. हा फॉर्म्युला कुठला आला, NS equals to 120 F upon P. हा आपला फॉर्म्युला माहिती आहे. Okay, so as by using this formula I am taking frequency, that is F equals to Pn divided by 120. Now I am substituting all these terms into this equation. Now average EMF per conductor, that is equals to 5p divided by 60 into, I am putting the value of n, n value is put kele. So I'll get, so here 2 into f pi volt. Now if there are z conductors in a series per phase, then average EMF per phase is equals to 2. हे फक्त हे काय EMF आहे, तो फक्त काय केलाय, तो एका कंडक्टर मधला EMF आहे. Okay, now but आपण काय केलं, we are assuming that there are total number of conductors are z. Okay, आम्ही काय केलं, आपण EMF फाइंड केलं. It is nothing but a conduct EMF in the one phase, sorry, one conductor only, but there are totally n z number of conductors, so taking as a 2f phi z whole. Okay, so I'm taking this, just I'm multiplying it by using the 2, so I get the 4f phi t whole. Now the RMS value of EMF per phase equals to 1.11 into 4f phi t, that is 4.4 per f phi t whole. So this 1.1 how we are taking, because of the form factor. Okay, this spelling mistake is there. So form factor, it is always nothing but a 1.11 here. So this would have been the actual value of the induced voltage if all the coils in a phase were full pitch and concentrated or bunched in a one slot instead of being substituted in several slots. But this is not being, so the actual available voltage reducing the ratio of these two factors. So actually voltage per phase equals to 4.44 kc kd into f phi t. Okay, you should remember only this part, actual voltage per phase 4.44 kc, coil span factor into kd, distribution factor into f, frequency, phi, flux per pole, and t is nothing but an turns, that is the number of turns. Okay, so this is nothing but EMF equation of alternator. This question may be asked for 4 marks in your MSBT exam. Now we are taking the next part, is nothing but alternator non-loading. So if I am getting the if I connected as known as, if I know as known at this EMF generated at the alternator is nothing but an E is equals to 4.kc kdf phi into t. But in actual practice, I am getting a terminal voltage is always less than induced EMF, and this terminal voltage is lower because of these three reasons. म्हणजे EMF जितके इंड्यूस EMF जितका आहे त्याच्यापेक्षा ऑलवेज मला टर्मिनल व्होल्टेज कमी मिळतं because of this system. Okay, so first is because of voltage drop due to resistance, that is RA, voltage drop due to armature leakage reactance XL, and third voltage drop due to armature reaction. Okay, that means simply armature current in the resistance I call to voltage drop due to armature reactions. Now second one, armature leakage reactance. When current flows through the armature conductors, fluxes are set up which do not cross the area but takes different path. Such fluxes are known as leakage fluxes. and this I into XL I call the armature leakage reactance. Okay, because of this two only, I am getting the lower voltage compared to the induced EMF of alternator. This is the induced EMF equation 4.44 kCkd F5T, and this is nothing but an actual voltage.